Hello and welcome to my channel. I'm Bound to Be Coding, and this channel is about a single-player 2D survival game hobby project that I'm working on called A Struggle to Survive. It is set in 1820 America during the time of the beaver trade and the Rocky Mountain rendezvous. If that piques your interest, I invite you to subscribe to this channel and follow along on my dev blog. You can find a link to the blog here on my channel. If you find this video interesting or helpful, please consider liking and subscribing. I really do appreciate your interest in my game. As you can see, I'm developing my game in the Godot game engine. As of this video, I'm running Godot 4.2.1 stable. I recently added zone detection to my procedurally generated Tilemap world. The code that I will show you today allows me to group water tiles together, allowing me to identify and give names to bodies of water like lakes, creeks, and rivers. This method can work in any scenario really where you want to group Tilemap tiles together for identification or other purposes. I plan to use this same method to name mountains, mountain ranges, and other parts of my map. This will make the game more interesting, uh, allow the player to roam around the map and discover lakes and rivers and mountain ranges and things like that. All right, let's jump right in. Before I show you the code, let me just show you what the code does. All right, so I'm in the game. Let me just open this up a little bit, and I will turn off fog and show the game world. All right, so there's the world that was just generated. This one is 600 by 600, and I am up here in the upper left corner, so this is representation of mountain. You can see here that I have a blue area on the map and this brownish area, this blue area here. There's also a greenish area. These are all water zones that have been identified during the creation of the world. And what I want to do is show you um, what this code does to identify these zones. So rather than bore you with walking all the way over there, even though I am walking faster than normal, I'm going to pause, skip over, and show you these two bodies of water. All right, here we are. We have arrived at this little guy up here, and it is called Libby Pond. Um, it's using my blue animated water tiles. It is 352 tiles in size, and so I will just bring that down a little bit, and you can see that this is an enclosed body of water. All the tiles share the same zone name, and that's what this code does. It allows you to identify a body of water, be it as big as a river or as small as a watering hole, and then give it a name if you so choose to do that. Here's a big river. This is called Riddle River, and it's brown. The animation I'm using here is the rapid animation that I have in my tile map. And again, this guy is 20,404 tiles. So it's a pretty big river. My game world wraps around so that the player never does see the edge of the tile map. And even though this little guy here doesn't look very large, if I scroll down to the bottom, you'll see that it's just picking up the tip here from the top. This is actually how big it is. So it's quite large. And that's what this code does. It allows me to group these tiles together, and with grouping, I can also do special things with this body of water as compared to another body of water. I could put certain fish in this water, but not other bodies of water. So there's a ton that you can do with just having the ability to look across your map and create zones where you can target certain types of functionality for your game. That's what I'm going to show you here. So let's take a look at the code and see how all of this works. Okay, so I'm in my world gen um, script, C# script. And for those of you that don't know, I am developing my game in C#. This is Godot 4. Back in when I had my game in Godot 3, I decided to switch from GD script over to C#. And since C# is the language I use at work, I'm a software engineer, very comfortable with C#. So I decided after I learned GD script, um, which is something I encourage you to do. Uh, Software developers should have the mentality of wanting to learn new things. I mean, that's just that's one of the major uh, necessities, if I could say that, of software engineering. If you're not wanting to learn new things, software engineering is not for you. Definitely not. There's always something new to learn. And I decided when I switched from Unity a couple of years ago over to Godot that I would port my game over to Godot and I would learn GD script. And I did. I learned it enough to read it, write it, comfortable with it. But when I found out that Godot 4 was coming out with support for uh, .NET Core 6, 7, and almost ready for 8, uh, I wanted to take advantage of C Sharp's improved features. It specifically with respect to speed and performance. C Sharp is blazing fast now, and I mean I remember the days when it wasn't so fast, and it is blazing fast now. .NET Core is very, very fast. So I want to take advantage of that and and it also allowed me to basically use some of the features of the language that are not provided with GDScript. GDScript is a fine scripting language. It does what it's supposed to do, but I want more power and flexibility, so I switched over to C Sharp. And of course, if I ever leave Godot, which I don't plan to, I love this engine. I can always take my C Sharp code with me. I don't have to convert anything. I just take it to another game engine that supports C Sharp. But I don't expect that that's ever going to happen. Not in the foreseeable future anyway. Okay, enough rambling. This is my world generator, and this method here, generate new world, produces my Tilemap world. And if you're interested in knowing about how to do this, I do have a video on this channel where I talk about how to create a Perlin generated game world using the Tilemap features in Godot 4. You're welcome to take a look at that. So what I ended up doing to create this zone feature is as I'm looping through my game world and I'm setting my tile definitions, one of the definitions has a value of 5, and that is the water. And so for each tile where the tile data is the first in this integer array is the tile type here. So if it's 5, then it's water. And so what I want to do is I want to establish some water tile depths, which is another feature that I added, the ability to have multiple depths in my water. And once I do that, I set the water tile in a separate dictionary from my normal Tilemap game world dictionary. So here I am setting the Tilemap dictionary record. This is one dictionary, and the water is set in a different dictionary, and it'll become obvious why when I start looking at this code with you. So we set the water tile. Once we've looped through and created the entire game world, then we generate our water zones next, and that's what this guy does, create water tile zones. So I'm going to jump there. Now what I'm going to do in this is we loop through the water tile dictionary. Now I say loop, but really dictionaries do not, you can't really cycle through them unless you parse out your key and do a, my key is a vector 2, so I could do a for each x, I could do a for each y, and then that would iterate over my tile map or my water tile dictionary, from left to right, from top to bottom. But there's really no need to do that. Um, when I for each over the keys in the dictionary, it's going to be totally random. It's just going to grab keys and it's just going to start processing each one of the positions, not systematically, but just basically top down, just for eaching over each one of them. And what I'm doing here is, and what I failed to mention here, when I establish my water zone, let's see if I can, okay, we've got our water. All right, so when I create my water tile that's going to be stored in this dictionary, this water tile dictionary, I give it the depth that's calculated in this method here, water tile depth here, and then I initialize the object, the water tile object, this class here, with a zone ID of null. So this is a nullable int value here, and I'm basically setting it to null at the very beginning. What that does is it allows me to iterate through the dictionary and check to see if that zone ID has a value. Now, if the zone ID has a value, then it doesn't need to be processed. But if it doesn't have a value, then we're going to do some processing with that particular water tile that is in that water tile dictionary. And of course, since we're calling it from world generation and we know that all of them have values of null, this is always going to call every one. Well, you'll see. There'll be some that won't make it into the call because we're going to be doing some updating. All right, so first thing we're going to do, we're going to find the water tile the next water tile in this for each that does not have a zone value. It's null. Zone ID is null. And we're going to check the neighboring tiles. So I'm going to just control click here and jump down. Now, what this code is doing is it's basically checking all the tiles around the tile that I'm trying to establish a zone ID for. So you can see up here as I for each over the dictionary, I have a zone ID that's null. It's not has a value, so that's null. We're checking the tile. So what we're going to do is we're going to create a zone list, which is just a list of type int, and we're going to establish a target. And this target vector to I is going to change. We're going to reuse this target. We're going to check the west tile to our current tile. And if that tile has we're going to try to get the water tile zone for that tile. And if it does have a zone, if that zone has already been established, then we're going to add that zone to this list of zones here. We're going to do the same thing for all of the cardinal directions and all 8 directions. Basically checking to see, hey, do we have a water tile that is next to the tile that I'm looking at? And if so, does that tile have a zone value? And so we're checking all 8 directions. When we get down here to the bottom, we're going to take our zone list and we're going to distinct that list. We're going to get rid of all the duplicates. And the reason we do that is because if you have a water tile that is in the middle of a large body of water, then all the tiles around it, have values, and those values might be duplicated. So we only need to know what the distinct list of values is. And so we distinct the list to create a new list. So zone list becomes a list of unique zone IDs instead of a bunch of duplicates, possibly. And then we're going to create a variable for the new zone that we're going to assign to this water tile that we're processing. Now, if the zone list count is greater than 0, then that means one of these adjacent tiles had a zone already. And we have decided in this method that we're going to choose the lowest valued zone. It doesn't really matter which zone gets chosen as long as there's a consistent implementation. And in this scenario, we're going to go with the lowest zone, which would be the first zone that would be created out of the adjacent tiles. Otherwise, if the zone list is 0, then we're going to create a new water zone. Now, new water zone is simply, this is another dictionary that I'm storing zone information in. I increment an integer to get the next zone. I create this water zone object, which just has a couple of properties to it, information that I want to store about the water zone. And I set the key to this new water zone ID that's been incremented. I then add the water zone to the water zone dictionary, and I return the ID back to the calling method. So at this point, I have a zone. It's either a new zone or it's an existing zone. Now, once I do that, I set the water tile, the tile that I'm looking at from our, our loop up here, our for each. I'm going to go ahead and I'm going to set that water tile's zone to be the new zone that we have either borrowed or created. Now, once I do that, I am going to remove the new zone from the zone list. And the reason I'm removing it from the zone list is because the next thing that happens is that I go through, I check to see if the zone list has zones in it. And if those zones are present, if during the process of checking all of the adjacent tiles, I discover that there's more than one zone that's touching this tile that I'm assigning this new zone to, then, and this is the secret sauce to this whole thing, what I'm going to do is I'm going to merge the water tile zones together so that those tiles that are touching my tile are going to become zoned with that tile. So we're going to merge those water tile zones together. Since the new zone doesn't need to be merged because it already has the value that I'm going to use, I remove it from the list because there's no need to rename zone 1 to zone 1 because all the tiles in zone 1 are already named or already have a zone ID of 1. So I don't need to worry about changing those. I'll just change the ones that are not 1. And that brings us to the merge water tile zones method. What I do here is I bring in my list of old zones. These are the zones that were adjacent to the zone that I just assigned to that tile. And the new zone, which is the new zone that I have assigned to that tile. And I go through the water tile dictionary and I for each over, I pick all of the, I for each over the zones. So for each one of these zones, I am going to check where the zone ID equals the old zone, and I'm going to go into the water tile dictionary. I'm going to change the zone ID for all of the water tiles of the old zone to become the new zone. And once I do that, at the end of this for each, there will no longer be any tiles in my water tile dictionary that are assigned to the old zone. So that means I can just remove the old zone from the zone dictionary because it's not needed. It's been merged with with another zone. So I repeat this process. Okay. Now the merging and the determination of, what zones are touching this zone that I've just created or assigned, all goes back to this first loop where I'm looping through everything. And the combination of these steps, checking the neighboring tiles and assigning the zone and merging water zone tiles together, the end result is that we have a game world where all the water tiles that are touching each other have the same zone ID assigned to them. And we didn't have to do anything recursively. We didn't have to come up with some fancy way of uh, bouncing stuff off of each tile in the game world to figure out what kind it was. Nothing like that. This is at the end of the day, really, it's a pretty simple thing. It's a simple concept of if water tiles touch, they belong together. And if they belong together, they need an ID. So we're going to pick an ID of one of them and make all of them that ID. And at the end, when we get to the end of the map, all the water zones will have their own unique ID, and they will all be, well, different sizes. So you can see um, back up here at the first method that's called from WorldGen, the create water tile zones. Once I've created the zones, then for my game, I assign water zone content. Now this method is where you will um, decide what differences do you want in your zones. This kind of puts purpose to the zoning. You're going to assign, I'm assigning here some water zone content. Now with me, I have a water zone name list, which is a list of names in a JSON file, and I want to use those names. I want to randomly pick one of those names to become the name of the body of water, whatever it is. But I also have rules regarding, in my particular case, I have three types of water, and with the three types of water, I have three animations. So I have calm water, flowing water, and rapid water. So my zones need to be, we need to identify the type of zone. I also need to identify the style of that water, that water zone. And this is where I'm doing all of my assigning. Now, my small bodies of water, a spring and a watering hole, and you can see a pond. These, um, well, the spring and the watering hole, they don't have names. They just have a. So it's going to be a spring or a watering hole. When I get to the bigger sizes for zones that are greater than 51, less than 500 tiles, they become ponds. And those ponds get a random water zone name from my list. And I move on, and of course, the bigger ones, the lakes and the creeks and the rivers, they all get names. And then when everything is said and done, I have my game world, and my game world has the zones with the various zone names assigned to them. Well, that's how I was able to implement zones. I do plan to do the same thing with my mountains. I want to take this big mountain here and I want to give it a name. I want to give this mountain a name and this one a name. And who knows where I'll go with this and how many things in the game, how many groups of tiles in the game that I want to name. This might be Sawyer's Meadow, or who knows. But it does give me excitement to think about the randomization of these zones and how we can use them to make the map a little more interesting than a bunch of trees and a bunch of grass and a bunch of water. Now, before I go, I'll give you um, some bonus content here for those of you that stuck around to the end of the video. I appreciate it. So let me show you. Let's see, what am I going to show today? Tell you what, let me jump to WorldGen, and I didn't really decide what I was going to include. Really depended on how much I rambled in this video. Let me see. So WorldGen, create our water tiles. We get in here, we assign our content, we get to the content. Okay, let me share with you a shuffle extension method. Okay, so I have this water zone name list. This is basically a list of string up in my water zone names JSON. Excuse me, I said JSON earlier. Actually, when I first did this, my water zones were in a JSON file. However, I realized that the design really wasn't flexible, and I needed to do some refactoring. So I ended up creating my water zones, not as fixed data in a JSON file, but as an object that could be stored in a dictionary. And so what I ended up doing was switching it over to just having my water zone names just be a text file containing the names of my water zones. And that worked out really well. I can add to this list over time and build it out, hundreds and hundreds of names, random names that I can use. Most of these names are actually related to um, the state of Wyoming, where the setting of my game is Rocky Mountain and the Rocky Mountain Rendezvous. Most of them took place, in fact, I think all of them maybe took place in Wyoming. And so these are rivers and lakes and streams and so forth that are there in back in that day, and those that are in the modern time, our time. So I wanted to be able to, instead of trying to loop through this thing, the easy way to get a random name from this list was to create an extension method that would shuffle this list. So every time I for each, every time I work on a new zone, I shuffle this list. Let's take a look at that shuffle method. This is an extension method. We instantiate a random, which is system random, and we basically shuffle whatever the type is that's coming in, the list of whatever. This is an iList of string, and this piece of code right here handles your shuffling. Very efficient and totally random, and you can use that snippet of code right there to determine or to pick from the list once it has been shuffled. So if we go back, what I end up doing is I basically, once I shuffle this list, I can then come down here, and for each one where I'm going to give a name, I just grab the first value from the list. And that value is going to be different because it gets shuffled. And so that's my shuffle extension method. Well, I hope you've learned something today. Um, I hope that if you're interested in following along in what I'm doing with this game, and I hope to continue to create videos specifically in C# for Godot 4. Um, but that's what I have today. I just the ability to create zones in your random generated Perlin noise tile map. Until next time, I'm bound to be coding.